Difference of two squares theorem. There are two ways to solve this. So raise your hand if you know one way to solve x squared equals 64. Hayden. Yes, we can square root both sides. Is the answer just 8? Leo. Yes, it is negative 8 and positive 8. If you want to put plus minus 8, you can. Or we can have positive 8, negative 8. All right, anytime you take the square root and you're solving, okay, so if you just have a random, what's the square root of 64? You would put 8. But if you're solving for a variable like that, plus and minus. And here's why. What's the other way to solve these? Anybody know? Nate in the back? Yes, set it equal to 0. And then do what? Vector attractor, x plus 8, x minus 8. That's a difference of squares. And we get negative 8 and positive 8. Okay, or if you want to do a little bit less work, you can put plus and minus 8 as one thing. I mean, the same thing, okay? All right, use the difference of squares theorem to find the solution to each equation. So we can just solve it. What's our solution going to be? Plus and minus. If it's not nice, we can just leave it as the square root of 14. If it simplifies, okay, simplify that root. But in this case, 7 times 2, there's no perfect square numbers in there. All right, we'll take it a step further. So go ahead and write that one down. X plus 9 squared equals 11. So this one has 2 steps. Okay, and you have to always square root first. Okay, we're isolating what's in the parentheses first. So we're going to square root both sides. Always do that first. And that undoes the square. So I just have x plus 9. On the right-hand side, the square root of 11 does not simplify. But what do I have to remember every time we're taking the square root? Plus and minus. Okay, so it goes in front of the radical. Then we're going to isolate the x by subtracting 9 from both sides. And we always put that 9 first, well, negative 9, and then plus or minus the square root of 11. We're going to leave our answer like this. Okay, so same type thing here. Kira, what are we going to do first? Yep, we're going to square root both sides. And we're left with x plus 1/7 equals. Always remember plus and minus. And Nate H, does the square root of 8 simplify? Yep, because it's 4 times 2, and the square root of 4 is 2. So the other 2 stays inside. Okay, and Angelo, what's the last step? Yep, so x equals negative 1/7 plus or minus 2 root 2. All right, we're going to do some trig word problems. So we have the angle of elevation and the angle of depression and the line of sight. All right, so we're in a hot air balloon. All right, right here. These are my eyes. So if we look straight out, okay, and I'm looking down at something on the ground right here, okay, this would be an angle of depression. So from the top going down is angle of depression. Right here. Top looking down. So you're always drawing a straight line to the ground right here, parallel lines. So from the top looking down, angle of depression. Now if I'm standing down here, okay, looking up at the hot air balloon, so from the ground looking up, that would be the angle of elevation. What's important about those two angles? Anybody? Okay, let's say this is 30 degrees. What do we know this is? 30 degrees. Why do we know those are the same angle? What's our reasoning? Yeah, those are alternate interior angles. You have parallel lines, so line of sight and the ground, okay, they're the same. So whether it gives you angle of elevation or angle of depression, if you draw a triangle, they are the same angle, all right? Okay, from an altitude of 2,000 feet, an airplane climbs to 5,000 feet at an angle of 12 degrees. How far does the plane climb? So we have to be able to draw the picture, which is the hardest part. And then we're going to use SOHCAHTOA to solve, okay? So we've got a plane that's starting at an altitude of 2,000 feet. So let's draw ourselves a lovely plane, and it's 2,000 feet above the ground. Okay, altitude, you guys, means height. Okay, it always means height. So I have 2,000 feet above the ground, and it's climbing to 5,000 feet. So the airplane is like getting higher and higher and higher and higher. And now over here, we're at 5,000 feet above the ground. Okay, and it's climbing at an angle of 12 degrees. What we want to do is we've got the ground down here, and we want to line up that line. So parallel lines, okay? So ground where it starts. So this angle right here is 12 degrees. So we're climbing at an angle of 12 degrees. Does anybody know what this is right here? Because we really only want this part of the triangle. What'd you say? Yeah, so this whole thing's 5,000. This piece is 2,000. So this is 3,000. Picture not drawn to scale, okay? So right angle right here. So you're always making a right triangle on these. And we're climbing. So how far does the plane fly in the climb? That means my x goes here because the climb is that slanted height, okay? So how far in the climb? All right, now we have a triangle. We really only need the 3,000, the x, and the 12 degrees. So we first want to label our sides. If this is the 12 degrees, okay, this side right here is opposite, adjacent, or hypotenuse, you guys? Okay, so here's hypotenuse. This side is opposite or adjacent? Opposite. And this side would be adjacent. So we are not using the adjacent side because nothing's marked on there, right? We are using the side we know, 3,000, and the side we want to find. So, SOHCAHTOA. So Jordan, which trig function do you think we're going to use? Yes, opposite and hypotenuse right here. So we have to write an equation using sine. So it's always sine of the angle. So what angle do we put here? 12 is equal to opposite, which is 3,000, running out of room, over the hypotenuse, which is x. We have a variable in the denominator, okay? So Hugh, if there's a variable in the denominator, do you remember what we do? Yes, we want to cross multiply. So I have x times sine 12. The x goes in the front. X sine 12 equal to 1 times 3,000, which is 3,000. And Bailey, what's the next step? Good. So we have to divide by the whole trig function. So divide by sine of 12. So 3,000 divided by sine 12, we can figure out how far the plane went on the climb. Anybody got an answer for me rounded to 3 decimal places? This was not enough space on my board here. I'm going to move that down. Ooh. Sam. Okay, you guys agree? All right. Yeah, Ian. Yes, you have to draw the triangle. Okay? Every time, you gotta draw the triangle. All right. Let's try one more. You are riding in a hot air balloon and can see an elk off in the distance. You measure the angle of depression to be 47 degrees, and you know that you're 400 feet above the ground. How far are you from the elk? So You're riding in a hot air balloon. So your hot air balloon is in the sky. Okay, so I'm going to draw a hot air balloon. Ooh, that was bad. Okay. So hot air balloon, you can see an elk off in the distance. The elk is going to be on the ground. This is my elk. Okay, here's me. Line of sight. Ooh, there's looking at the elk. Boom. We're making eye contact. All right, you should probably face that way then. So anyways, you measure the angle of depression to be 47 degrees. So when you're doing an angle of depression, again, you want to draw the line of sight and the ground. Okay, line of sight and the ground. So the angle of depression, meaning line of sight looking down at the elk, is 47 degrees. Hi.
Ground, that's probably the next thing we want to label. So your little hot air balloon, you're 400 feet off the ground. How far are you from the elk? All right, so how far I am from the elk, we're going to use the hypotenuse again because we want to know how far from here down to the elk. So if I'm just going to turn this guy into a triangle. We have the ground here. And what did I know about this angle and this angle right here? They're equal, yeah. So I'm just going to relabel this one down here at 47, so I have a triangle that we're more used to seeing, 47 degrees. 400, how far are you from the elk? So if we use this 47-degree angle as our reference angle, this side, again, is going to be my hypotenuse because I have my little right angle down here. So this is my H. What is my 400, adjacent or opposite? Opposite. Great. So now I can come up with another equation. Again, I'm going to use opposite and hypotenuse. So if I were to write out my SOHCAHTOA, we get to use sine again because I'm using my opposite and my adjacent, or my opposite and hypotenuse side. Sorry. So I'm going to have sine 47 equals opposite, which was my 400, over my hypotenuse, which is what I'm looking for. And then we can solve for h by cross multiplying. So h sine 47 equals 400. We're going to divide both sides by sine 47. So h equals 400 over sine 47. Right? So someone with calculator. 3 decimal places, Leo. 0 feet. Does everybody agree? 530? 5, 4, 6. Oh my gosh, what was I hearing? Okay. 5, 4, 6. Is that right now?
You guys make sure it always makes sense. Obviously, if you get a negative number, you did something wrong because there's not a negative distance. If you get something that doesn't make sense for your picture or what your kind of feet you're talking about, then make sure it kind of makes sense before you put an answer down. And that's it, you guys. If you can draw the picture, you can probably get the problem correct.